The mapping of Venus refers to the process and results of human description of the geological features of the planet Venus. It involves surface radar images of Venus, construction of geological maps, and the identification of stratigraphic units, volumes of rock with a similar age. Satellite radar provides imagery of the surface morphology by using the physical properties of wave reflection. Long wavelength microwaves are used to penetrate the thick, cloudy atmosphere of Venus and reach to the surface. Different surface features reflect waves with different strengths of signal, producing images from which the maps are constructed. After collection of the images of the Venusian surface, scientists started to map and identify different geologic materials and units according to distinctive surface features. Different groups of scientists analyzed different mapping areas, schemes and interpretation of features observed, to produce a classification of the units and comparison of their mapping. Before the development of radar-based observation, the thick yellow Venusian atmosphere hid surface features. In the 1920s, the first Venus ultraviolet project captured the thick atmosphere of Venus, but provided no information about the surface. From 1961 to 1984, the Soviet Union developed the Venera Probes for surface mapping by radar. The Venera 4 was the first lander to make a soft landing on Venus. The probe operated for about 23 minutes before being destroyed by the Venusian atmosphere. The Venera series space probes returned radar images of the Venusian surfaces, shown as below with the landing locations of the probes. The global surface of Venus was first mapped by the Magellan orbiter during 1990-1991 with 50 km spatial and 100 meters vertical resolution. During 3 orbit regimes, the surface images were transmitted back to the Earth. These 3 orbiting motions of the spacecraft are called mapping cycle 1, 2 and 3. During the mapping cycle 1, 54.5% of the surface was mapped, mainly the South Pole regions and gaps from cycle 1 during May 15, 1991 to January 14, 1992. Combining cycle 1 and 2 results in a total coverage of 96% of Venusian surface mapped. Cycle 3 filled remaining gaps and collected stereo imagery of approximately 21.3% of the surface, increasing the total coverage to 98%. The use of interferometric synthetic aperture radar for mapping Venus has been proposed, instead of surface mapping by SAR as done by previous missions. INSAR would measure the terrain motions during events such as earthquakes or tectonic movements. By performing the radar mapping at 2 separated times over the same area, the terrain changes could be revealed. From the Magellan mission data, 3 types of images have been produced. Meter scale slope image. SAR images provide the highest resolution dataset. Microwave radiation is used to penetrate the thick atmosphere and map the surface of Venus. The SAR images are black and white images, which show the surface features using the intensity of radar return, either due to surface roughness or orientation. For SAR imaging, spacecraft do not point directly downward but slightly to the side, anywhere from about 10 degrees to 45 degrees. If the surface being mapped is smooth, the incident radar pulse will be reflected away from the spacecraft, resulting in a weak echo, which is represented by darker regions SAR images. On the other hand, if the surface is rougher, then more of the radar wave will be backscattered, and the intensity of echo will be stronger, which are represented by brighter areas in SAR images. SAR images do not provide the color of surface, only the intensity of reflection of radar waves on the surface at a particular incidence angle. For example, when there is a light source shining on the blue cap on the left of Venus from the SAR data collected from the mission, called the Magellan FBIDRs, the maps has a coverage of around 92%. The resolution of it is 75 meters pixel, which is the highest resolution of Venusian map. Topographic images were collected using radar altimetry, compared to the SAR images. The topographic images have a significantly lower resolution of around 3 to 5 kilometers pixel. These images show lower elevations with darker pixels, with higher elevations are shown with brighter pixels. Despite of the low resolution, it is useful to study the regional feature of Venus, including initial evidence for the existence of rift zones. There are 3 types of topography on Venus. The surface observation include impact craters, volcanoes and lava flow channels, which give clues to estimate the surface age. Possible global resurfacing events, tectonic activities, internal structure and surface processes. Different missions have mapped different cartographic quadrangles of the surface of Venus. They applied different mapping schemes and came up with different classifications of Venusian units. Here is a table comparing the different mapping scheme and unit identification by the Magellan Ski.